Hey there, everybody. Welcome back. We're getting ready to pop into some complex fractions. I don't know if I think we touched something like this in our earlier section in chapter 1, but we didn't have any variables in it. So we're looking at complex fractions. This is 5.5 in Blakely's textbook. And maybe we'll do it in 2 parts. And maybe a better way of saying this is complex rational expressions. All right. So this is where we have fractions and fractions. Fractions inside fractions. Or if you've seen the movie Fraction Inception. That's an old movie though, and people may not get that. So, some rules to live by. If you've got a complex fraction, if the bottom is a single fraction, multiply top and bottom by the reciprocal of it. So that's actually the easiest scenario. Otherwise, you need to find the LCD of all the inner or smaller fractions. And at that point, we will multiply top and bottom by the LCD. Maybe I'll call this B1, B2, and B3. Nope, not in B3. This is just going to be C. Reduced to lowest terms. So you're going to either do A or B, and then you're going to reduce to lowest terms. All right. So, examples. 6 over x minus 5 plus 7 all over 8 over x minus 5 minus 9. Okay, so the bottom is not a single fraction, so A doesn't apply. If it's just a single term, we can do it. Otherwise, or a single expression, we can do it. Otherwise, we got to find the LCD of all the inner fractions. That one, I've got an x minus 5 on the first one. No denominator here. X minus 5 here. No denominator here. The LCD is x minus 5. It's the only denominator there is. So what we're going to do is we're going to multiply top and bottom by x minus 5. So this step I'm going to show written out a little bit better but this step is kind of skipped to understand what you're doing. Oop. I'm multiplying this by x minus 5 over 1 basically. And then I had plus 7 times x minus 5. Down here, I had 8 over x minus 5. And I'm multiplying, when I distribute, I'm multiplying this by x minus 5. And I'm multiplying the minus 9 by x minus 5. So there's 4 things to distribute to here. Those 2 terms and these 2 terms. The point of multiplying by the LCD, as you'll see here, is it cancels out the denominators of the inner fractions. So I call this big fraction bar, that's like the outer fraction. And then this is a fraction inside the fraction, the big fraction. So I call that the inner fraction. When that cancels there, we have 6 left over plus, and I'm going to leave the 7 times x minus 5 here for a second, just to illustrate slowly what's going on there. So notice we don't have fractions inside fractions anymore. Now we're good to go. We're going to clean this up. I've got 6 plus 7x minus 35 over 8 minus 9x plus 45. This is 7x minus 29 over negative 9x plus 53. And I think 29 and both 53 are prime. So that's a done deal right there. Okay. Let's go with another one. We're going to have 1 over x plus h squared minus 1 over x squared all over h. All right, so the bottoms is a single thing, but if I multiply with 1 over h, I'm still going to have to get a common denominator. I want to get rid of that. Let's multiply by the LCD. The first fraction has x plus h squared. I'm going to say h over 1 here. X plus h squared is a term. The h over 1 doesn't have anything. So the LCD is x plus h squared times x squared. So that's what I'm going to multiply top and bottom by. We get x squared, x plus h squared over x plus h squared. I'm doing it slowly one more time. Minus x squared, x plus h squared over x squared here. And the bottom just has it all multiplied out, where I'm putting the x squared first now on both of them. So here that cancels, and I'm left with an x squared. Here the x squared is canceled, and I'm left with x plus h squared. And I'm going to move this on to another page real quick. I'm going to factor or multiply out that second term. I've got minus x squared minus 2hx minus h squared all over h x squared x plus h squared. Combine like terms, the x squareds go away. And I'm left with negative 2hx minus h squared, or h x squared x plus h squared. I can factor out an h here and probably the negative. Let's take out the negative. And I'm left with 2x minus h plus h. I factored out the negative. all over h times x squared times x plus h squared. The h's cancel. And I'm left with negative 2x plus h over x squared, x plus h squared. Ta-da! If you decide to take Math 35, switch to a STEM major, what we did is just worked out steps for the derivative of 1 over x squared. This was something you will do in calculus. There's some more steps in it in the calculus. You deal with the h, but that's what it is. All right. Let's throw in another problem in the mix. 1 plus 2 over x minus 8 over x squared all over 1 minus 3 over x minus 28 over x squared. And you should be able to see relatively quickly the LCD is x squared. So I'm going to multiply top and bottom by x squared. If I do, I get x squared plus 2x squared over x minus 8x squared over x squared. X squared on bottom minus 3x squared over x minus 28x squared over x squared. So the x squared over the x's, x squared over x just reduces to x. I have x squared, that becomes a 2x. Here, the x squareds cancel. Here, the bottom one cancels, and it cancels out the exponent. Same here. And we have minus 8. Here we've got x squared minus 3x minus 28. So let's factor. This is x plus 4, x minus 2. This is x plus 4, x minus 7. And when we reduce, those leave behind a 1. And we're just left with x minus 2 over x minus 7. Now note, we don't want x to equal 0 for the first fractions. And we don't want x plus 4 to equal 0 or x minus 7 to equal 0. Those are all bad. The x equals 0 comes from up here. And the x plus 4, x minus 7 comes from after we cleaned it up. We can't have any of those equal 0. And it seems kind of unimportant now, but when we do rational equations in 5.6, you can see that table of contents over there. That domain, those domain things, the domain restrictions become pretty important. That's what everybody calls them, domain restrictions. I like to call them domain violations. But they're where the domain is restricted from being all real numbers. All right, ready for more? I thought you might be. You guys are a tough crowd to beat. I got 4 over x plus 7, and then plus 6 over x plus 2. And then in the big denominator, I got x plus 5 over x plus 7. You know, in hindsight, I'm thinking rule A that I gave you isn't helpful here. Because if I just flip and multiply by this, I still have a denominator to deal with. So I'm going to come back here and I'm going to say probably not that helpful. And I'll show you why. We'll do it here. I'm going to do it right here. So I said multiply by the reciprocal. There's a single fraction on bottom. I'm going to multiply by the reciprocal. What happens is these cancel on bottom, leaving behind ones. And up here, we can distribute. I've got 4 over x plus 7 over x plus 7 plus, oh, and an x plus 5, sorry. So that's the, you know what? I'm going to just line it up. That's the new part. And then we've got plus 6 over x plus 2 times x plus 7 over x plus 5. And the bottom turns into a 1 right here. So we don't have a big fraction anymore. We're still going to have a fraction though. We can see the x plus 7s cancel. And I'm left with 4 over x plus 5 plus 6 times x plus 7 over x plus 2 x plus 5. They still don't have a common denominator, but I think we can see these two are alike other than this is missing x plus 2. So that's why I was saying it may not be that helpful because you may have to do a lot more LCD work. Here I didn't have to. I can just find the LCD real quick. And now I'm just going to distribute and combine together. I've got 4x plus 8. That's my first fraction. Second fraction is 6x plus 42. Denominator is x plus 2, x plus 5. I combine together, I got 10x plus 50 over x plus 2, x plus 5. Looks like I can factor out a 10. And I can cancel out the x plus 5s, and I'm left with 10 over x plus 2. It's worth noting x plus 7 cannot equal 0. From up here, x plus 2 cannot equal 0, and x plus 5 cannot equal 0. So those are the domain restrictions from all real numbers. Or what I call domain violators, because I like to abbreviate. It stops it from being all real numbers. All right, you ready for more? Let's pause it and let's do the next part, and I'll make a second video. Peace.